Hi, Assalamualaikum and good morning everyone. Okay, so how are you today? Teacher hope you are fine and have you take your breakfast? Dah sarapan ke? Okay, so if you are ready, this will be our third online lesson for physics. Okay, and today we are going to try to finish the remaining 3 questions in the module Cakna. Alright. So if you are ready with your module, okay, so let's take a look at my slide. And I hope you have tried this question. We have question 11, 12 and 16 remains. Have you tried on them, everyone? Have you tried these 3 remaining questions, 11, 12 and 13? Siapa yang dah siap 3 soalan ni? I see your name. Those who have finished these 3 questions. Okay, so before that, as you can see in my screen now, this is my YouTube channel. You can just type my name in the YouTube, and the previous video for our previous classes can be found there. You can rewatch them if you need. Okay, and I would like to thank you for those who are responding to the attendance list in the second lesson. Okay, last Wednesday. Okay, before that, can you hear me clearly? Can you type in the live chat if you can hear me clearly? Boleh dengar cikgu dengan jelas tak? Tolong respon sikit dekat live chat. Okay or not okay? If you can hear me clearly, kalau boleh dengar cikgu dengan jelas, you please type okay in the live chat. Okay, can you please respond? Okay, very good. Thank you, Xuan Ling. Okay, yes. Common cubing, who is this? Common cubing, are you from Bagan Jaya or outsider? Ku Yi Heng. Okay, thank you very much for responding. Okay, so without further delay, let's begin our lesson today. Okay, class? Okay, question 11. Okay, this is question 11. Can you tell me which chapter is this? Oh, Tat Guan. Okay, hello Tat Guan. Thank you for identifying yourself. Okay, question 11, you are given diagram 6.1. Okay, in question A, diagram 6.1. So I zoom the diagram for you. So this is diagram 6.1. Alright, can you tell me which chapter is this, class? Which chapter is this question relates to? Okay, anyone? Which chapter? Can you identify which chapter is this question relate to? It shows an arrangement of electronic components that are connected to a cathode ray oscilloscope, CRO, and a wave pattern is produced on the screen of the CRO. So the first question, you are asked to name the electronic component label M. So this is a question on chapter 4, electronics. Alright, so what is the name of the electronic component label M? So where is M? This is the electronic component label with M. What are the name of this component? Apa nama component ini? Can you type in the live chat what is the name of component M? Okay, please write your answer or share your answer in the live chat. What is the name of electronic component M? Okay, I'm waiting for your answer. It is, what is M? So M is diode. Yes, Songjun, M is diode. So M is diode. You must be very sure. Don't write the question mark at the back. It is diode. Yes. So you write there, M is diode. Yes, Jinqian, diode. Very good. Okay. Okay, next. Okay, question B. Now you are given diagram 6.2 and 6.3. If you look at this diagram, they label diagram 6, 6.1, 6.2, 6.3, which means in the real SPM paper 2, this question is for question 6. Okay, who knows question 6 in paper 2, section A, allocates how many marks? Who remembered question 6 in paper 2, section A, allocates how many marks? Berapa markah? How many marks? If you count all together, question 6 allocates 8 marks. Okay, 8 markah. Question 6 and question 5 is the same type of questions. They allocate 8 marks. 8 markah. Okay, now in diagram 6.2 and 6.3, it shows the wave pattern on the CRO screen when a capacitor with a capacitance of 10, how to read this? 10 microwatt. Capacitor with a capacitance of 10 micro, this is we read as microfarads. F-A-R-A-D-S. Okay. 10 microfarads. F-A-R-A-D-S. The unit is named after Michael Faraday, a well-known physicist. Okay, Michael Faraday. 10 microfarads. F-A-R-A-D-S. And 20 microfarads in diagram 6.3. Okay, observe these two diagrams. Number 1, compare the capacitance of the capacitor. So you can see in diagram 6.2, the capacitance is 10 microfarads. Okay, while in diagram 6.3, the capacitance of the capacitor is 20 microfarads. So how do we compare the reading? How do we compare the value of the capacitor? Which one, are they the same? Are they different? If they are different, which one is higher? Which one is smaller? Okay, so how to compare? Can you share your answer? How do we compare the capacitance of the capacitor? Which one is higher? Okay, diagram 6.3 is greater than 6.2. We can write in this way. Diagram 6.3 is greater than diagram 6.2. Remember, this is a structure question, so we can straightforward go to the answers. Okay, don't have to write the full sentences. But in essay, you must write the full sentences. The capacitance of the capacitor in diagram 6.3 is greater or higher than in diagram 6.2. Okay, for structure, you just straightforward write come to the answer. Which one is higher? Which one is lower? Yes, means one. Very good. 9.3 greater than 6.2. Sorry, 6.3 greater than 6.2. Yes. Okay. Now second question, B2. Now compare the smoothness of wave pattern on the CRO screen. Okay. So let's take a look at the screen now. This is the screen of the CRO. You can see this is the wave pattern. Okay, this is the wave pattern on the diagram 6.2, and this is the wave pattern shown in diagram 6.3. So how can we compare about the smoothness? Which one has a greater smoothness? Which one has a lower smoothness? Mean which wave is more smooth? Which wave is less smooth? Which one is smoother? Mana yang lebih more smooth, the wave pattern, 6.2 or 6.3, or are they the same? So what do you say? Sleepy says, Songjun says 6.3 greater than 6.2. Yes. Okay, so you can see the smoothness of wave on the CRO screen show in diagram 6.3 is greater. So diagram 6.3 greater than 6.2 in terms of smoothness. All right. Okay, so that goes for B2. Okay, now we go to B3. Okay, question 3. Compare the magnitude of the peak voltage, VP. Okay, now question 3 is the peak voltage. So where to look at the peak voltage? If you zoom into this diagram, this is the peak voltage. Okay, it labeled as VP, the peak voltage, the height of the voltage from the center. So this is also VP, the height of the peak voltage from the center. So how to say about the peak? Are they the same or are they different? If they are different, which one is higher than which one? Okay, so how to compare the magnitude of the peak voltage? The peak voltage, yes, Chan means one. The peak voltage is the same. Okay, you can write same or you can write 6.3 equal to 6.2. Okay, sama, the peak voltage has the same height. Okay, now number 4 is time to do the relationship. Okay, how do we relate the capacitance of the capacitor and the smoothness of the wave pattern? Okay, how do we relate the capacitance of the capacitor and the smoothness of the wave pattern? So just now we say the capacitance in diagram 6.3 is higher or greater. And also the smoothness in diagram 6.3 is higher or greater. So how do we relate capacitance of capacitor and the smoothness of the wave pattern? So how to write the relationship? Please share your answer. Type your answer in the live chat. If you can't see the screen clearly, actually you can adjust the resolution of your laptop or your handphone. Okay, you can adjust the resolution to the highest pixel, 720 pixel, for example. Okay, so how do we write the relationship, class? Okay, we can write the relationship as this. The capacitance of the capacitor increases, so the smoothness of wave pattern increases. Or you can simply say increase, increase. Okay, higher, higher, greater, greater. Okay, so this is how we write the relationship for capacitance of capacitor and smoothness of wave pattern. All right. Okay, so can we go to the next questions? Okay, you can also capture the screen if you want to get the full answers. But later you can also come back to this video to get the full sets of answers. All right. So now we proceed with the next questions. C. Okay, now 11C. C, name the type of rectification occurs. Okay, name the type of rectification occurs. Okay, just now in the first question, you have named M is a diode. Okay, diode is used as a rectifying circuit. We learned before in the school before. All right. So if you remember talking about rectification, there are two types of rectification. Okay, we have two types of rectification. Who knows the first type of rectification? Okay, yes, it is greater, greater, or as you can say greater, greater. Okay, for the previous questions. Okay, who remember the two type of rectification process? What are their names? The first type, when we are using a single diode. Okay, if we are using a single diode, one diode, it will be half-wave rectification. Yes, Jing Qian, very good. So now you can see 4 diodes in the diagram. So 4 diodes mean it is full-wave rectification. Okay, remember class, if one single diode only, it is half-wave rectification. And for 4 diodes, it is full wave rectification. So answer is full wave rectification. Okay, now D, explanation. In this diagram 6.2 and 6.3, you can also see an electronic component capacitor. Okay, there is a capacitor placed in the circuit which is used to smooth out the output voltage. Okay, so the question is explain how the capacitor smoothen the output voltage. So how does the capacitor smoothen the output voltage? So how to explain? Actually, you can say what happened to the capacitor when the current is flow through it, and what happened to the capacitor when the current stop flowing to the circuit. Okay, what does the capacitor do when there is no current flow to the circuit, or when there is no voltage supply to the circuit? Okay, so how we write this? Anybody wants to share your answer? Okay, just now Jing Xian say yes, full wave rectification. This is for C. Okay, and this is the answer for the previous questions. Greater, greater. Okay, so how can we explain? First mark, you can say what happened to the capacitor when the current passed through it. So you can say capacitor is charged, okay, when the current flow. Capacitor is charged when the current flow. And then later when there is no current flow to the circuit, so what will the capacitor do? Capacitor will be discharged, okay, when there is no current flow. Discharge means the capacitor supply, okay, the capacitor will discharge its energy, okay, and supply the voltage to the circuit. All right. Okay. When it is charged means it collect the energy. And when there is the current stop flowing, it will discharge or release this energy and supply voltage to the circuit. So this is how we explain how the capacitor smoothen the output voltage. Okay. So can we move to the next slide? So this is the answer for question C and question D. All right. Okay, next. Okay, so we've done with question 11 altogether, 8 marks. Remember, question 11 represent question 6 in paper 2, section A. Okay. Okay, so now we go to question 12. Question 12 is an essay questions, and it is also question 12 in the real SPM paper. Okay, diagram 12.1 and diagram 12.2 are given. It shows a plant watering system. So in the first diagram, you can see this is the plant watering system. This is where the water tank is. It is supplied to these tomato plants. Okay, and in diagram 12.2, it shows to you the circuit. Okay, this is the circuit of the plant watering system. So what is the information given in this question? When the condition of the soil is less than 5 volt. Down here, you can see an electrode. Okay, this electrode is embedded into the soil. Electrode ini kita tanam di dalam tanah. So it will act as a detector to detect the dryness, okay, of the soil. So the electrode is used as a detector to detect the level of dryness or moisture of the soil. And it is said that when the condition of the soil is less than 5 volt, okay, so the soil is considered as dry. If the electrode record a reading which is less than 5 volt, so it give a signal that the soil is dry and it need to be water. It need to be supplied with water at that moment. So this is an automatic plant watering system. For example, if you are away for a longer period, you went for a vacation, so your plant will be continue supply with water so it won't die. So dia takkan mati. Okay. So based on the diagram, name the component label J. So first question, name the component label J. So this is where J is. So what is the name of this electronic component, class? Can you please type the name of this component? Do you remember this symbol? Okay, what electronic component J is? Okay, what is the name of electronic component J? Okay, I zoom the diagram again. So this is J. Can you recognize this electronic symbol? Chin Wei Lun said it is a transistor. Yes, very good. It is a transistor. Or you can be more specific. What type of transistor? Yes, this is NPN transistor. Yes, Wei Lun, this is transistor. So you can say the name is transistor or NPN transistor. Okay, 1 mark. Okay, second, state the function of component J in the diagram. So this transistor is used for what? Okay, what is the function of placing a transistor there in this circuit? This transistor acts as what? Type your answer in the live chat. What is the function of this transistor? NPN transistor. It is used as... I don't see any answer yet. Can you share your answer? What is this transistor used for? Kita guna transistor ini untuk apa? It is used as... Just now I give you the clue. This is a automatic plant watering system. Okay, this is an automatic plant watering system. So remember, transistor act as what? Transistor ni guna untuk apa? It is act direction of current. What do you mean? OSAS 01. Who is this OSAS 01? Can you identify yourself? OSAS 01. What is the function on component J? Component J is used as an automatic switch. Oh, Wei Liang. Okay, sorry. And it's not a current amplifier. Bukan current amplifier. Here it acts as an automatic switch. Okay, as an automatic switch. The transistor is act as an automatic switch. Current amplifier is another users, but in this system, the transistor is used as an automatic switch. Okay, class. So if you answer wrongly, please correct your answer. It is function as an automatic switch. Okay, next. Okay, automatic switch. Okay, next, question 3. Okay, based on the diagram, this is a 4 marks explanation. Based on the diagram, explain how the watering system works. Okay, so you are asked to explain how this watering system works. So where to begin with? How to begin our explanation? What must we write first? Apa yang you kena tulis dulu? Okay, can you share your answer with the others? How to explain the watering system? How do this watering system works? Okay, 4 markah. Any idea? You want to share your answers? See can get marks or not? Or from 4, how many you can hit? Okay, you can share with the others. Based on diagram, again, explain how the watering system works. Okay, anyone? Anyone dare to share their answer? You don't have to be shy. If you get wrong, I will correct them for you. Okay, we are now learning, we are now revising. So it is good for you to have a clear picture on how to write the explanation, the best explanation for these questions. Okay, number 3. Okay, first you can say, you can begin with the electrode. Okay, the electrode. The electrode detects. Okay, the electrode detects dry soil, or the electrode detects low voltage. Okay, or the electrode read low voltage. Okay, first. And then what happened? Okay, what happened when the electrode detects a low voltage, which is below 5 volt? So it means that the voltage across the variable resistor is high. Okay, you can see that the electrode is placed on top. Okay, is placed on top, and this is the variable resistor. It is placed at the base circuit. So this variable resistor, 50 kilo ohm, act as our base voltage. Okay, now the base voltage is higher. Okay, base voltage is higher than the voltage above here, which is less than 5. So what happened to the transistor when the base voltage is high? So when the base voltage is high, remember what will happen to the transistor? So there will be a base current flow to the transistor. Remember class, when the base voltage is higher, so there will be a base current, enough base current flow to the transistor, which means that the transistor will be switched on. Or you can say the transistor will be activated. Activated means it will be switched on. Okay. And finally, there will be a current flow to the collector. Okay, collector current flow, and it will switch on the relay switch at this part. Okay, you can see that the circuit is connected to a relay switch here, and this is the secondary switch, okay, which is connected to the plant watering system. So when the relay switch is switched on, it means that the secondary the secondary circuit will switch on. Or you can say the watering system switch on. Okay, so this is how we write the explanation. We begin with the electrode. It detects that the dry is soil, mean the above voltage is lower, so the voltage below or the voltage at the base is greater. So when we have a high voltage at the base, mean base current flow to the transistor. Transistor is switched on. So current flow to the collector connected to the relay switch. Relay switch is switched on. So the secondary circuit is switched on. Finally, the watering system switch on, or the watering system works. Okay, so this is the full explanation for question 12.3. Okay, next. Okay, we go to the long essay questions. Look at this washing machine. It's very beautiful. My dream washing machine. So later, who those of if you get A plus in your SPM for physics, you can collect money and buy this one for me. Can or not? Boleh tak beli satu? Cikgu lama dah nak aim ini, the front loaded washing machine. Okay, cantik kan? Okay. This diagram show an automatic switch. Automatic washing machine. It will only operate. You can highlight this important information. Only operate when the start button is on, the lid is closed, and suitable water level detected. So in order for the washing machine to operate, it must obey the three conditions. Number one, start button must be on. Second, the lid must be closed. Penutup dia tu kena tutup. Okay, and a suitable water level detected. Then only it can operate. Okay, so you are required to investigate the characteristic of the automatic washing machine given in the table. Okay, so where the table is? So this is the table. You are given with 4 choices of washing machine. Okay, first we have washing machine P and Q. And this is the characteristic given. The load capacity means how many clothes you can put in. This one can hold up to 7 kilo. For Q can hold up to 10 kilo, 10 kilogram. And this is the specification. It shows the circuit. Okay, the circuit board of the washing machine consists of outer controller here, X and Y, and the inner controller we have Z. Okay, and then for Q, this is the specification show of the circuit. Can you tell me for P, what type of gates here? Okay, for P, the outer controller, do you recognize this symbol? What gates is this? What is the name of these gates? The outer controller for washing machine P. Can you share your answer in the live chat, class? What type of logic gates here? Okay, for outer controller of P, and for inner controller, what gates is this? Who remember the name? Dylan, see which one do you mean? Okay, yes, this one is O gate, and for the inner controller is this one is O gate. Yes, very good, Vinci, very good, Dylan. Liang Jinqian also, Song Jun. Okay, this is O gate. Okay, auto controller for P is O gate, and for the inner controller, yes, inner controller is N gate. How about Q? Okay, how about Q? Yes, Vinci. For Q, both outer and inner controller is made of N gate. Yes, very good. Okay, now let's take a look at R and S. Okay, washing machine R can support up to 9 kilogram load. For S, can support up to 11 kilogram loads. And this is again the outer controller and inner controller for both. For R, again, it is AND gate for outer. Yes. Hello, teacher. Hey, Jansen. Tan Jensen. Which Jensen here? Are you the previous, my former students? Okay, and this one is the inner controller or gate. Okay, and for S, outer controller is O gate. Inner controller also O gate. Okay, please remember class, you have to be alert. You have to very clear what type of gates we are dealing with here in this question. Okay, so this is the key to all X, Y, and Z. What is W, X, Y, and Z? W is the mass sensor. Okay, X is the start button and Y is the lead and Z represent the water level sensor. Okay, if you refer back to this table, P and R, it doesn't have the mass sensor. Okay, P and R doesn't have the mass sensor, but for Q and S, it has a mass sensor. It has an additional features. Q and S has additional features, which is the mass sensor. Okay. So your task is to explain the suitability of each characteristic and determine the most suitable washing machine to wash clothes and comforters efficiently. So remember, in your reason, you cannot say to wash clothes and comforters efficiently. Don't write that reason in your explanation. Okay, so how to choose which washing machine is best to buy, P, Q, R, or S? So first characteristic, the load. The first characteristic is the load, right? So what can we say about the load? Okay, we go back to the question, to the questions. Okay, first talk about the load capacity. Okay, the load capacity. So which one is a better choice? Okay, low load capacity or high load capacity? So which one is a better choice? Low load capacity or high load capacity? Definitely, we choose a washing machine with the high capacity. Okay, high load capacity. Yes, very good. Hi, Vinci. Yes, hi. Song Jun, yes, hi. Wei Liang, yes, hi. Okay, high load capacity. So what is the reason of choosing high load capacity? Okay, why you are choosing a washing machine with a high load capacity? Give a simple reason, a logic explanation. Okay, so with high load capacity, what will happen? It can wash greater volume or can wash greater mass of clothes. Mean you boleh basuh lebih banyak baju. Okay, wash more clothes at once. Yes, Vinci. True, very good. Okay, wash more clothes at once. Boleh basuh sekali jalan saja. Okay, you don't have to wash for the 2-3 times. Okay, so can wash more clothes? Yes, true, means one. Or wash greater volume or greater mass of clothes. Okay, second characteristic. Okay, characteristic number 2, what to write? Okay, characteristic number 2, what to say? You can say with or without mass sensor. So which one is the better choice? So we choose a washing machine with a mass sensor. Okay, have mass sensor. Okay, what is the advantages of choosing a washing machine with a mass sensor? So why do you think the mass sensor must be included? Okay, can you share your answer? Why it is better with mass sensor? So that, think logic explanation, reduce water using. Okay, Wei Liang say reduce water using. Who else? Jin Jie said to ensure not too much water in the washing machine. Okay, Min Swan say prevent overload. Okay, who else? No, the mass of the clothes can be washed at one time. Okay, so let's take a look at the answer. So we can save water. Yes. So reduce water using or save water or to detect suitable water level. So the water will be flow in based on the mass of the clothes inside. If you put more number of clothes, mean the water level will be higher. If you put less clothes, mean the water level will be lower. So this is the reason of having a mass sensor. So we can save water or it can detect suitable water level according to the mass of clothes we place in. Alright. Prevent overload. You can prolong your answer. Overload in what? Prevent overloaded. Okay, boleh extend sikit your answer, Chan means one. Prevent overloaded of water or prevent overloaded of clothes. Boleh. Okay. Okay, third characteristic. Okay, the auto controller. So which type of gate is a better choice? AND gate or OR gate? I quick it too fast. I showed to you the answer already. So for the outer controller, we choose AND gate. Okay, we choose AND gate in the outer controller. Okay, why we choose AND gate at the outer controller? Why not OR gate? Anyone? Why we must use AND gate at the outer controller? Okay, the answer is, what is the reason? So that the circuit can operate. Okay, to make the lid close when the start button is on. Remember, at the front part of this question, they give you the 3 conditions this washing machine must obey to operate. Number 1, the switch button must be on, plus the lid must be closed and the water level. Okay, so it must obey the 3 condition, means we have to apply AND gate in the auto controller. Okay, so how about the inner controller? What type of gate? The inner controller, AND gate or OR gate? Okay, now type your answer for the inner controller. AND gate or OR gate? For auto controller, we use AND gate. How about the inner controller? Songjun say OR gate. Why do you say OR gate, Songjun? Can you share your reason? Wei Liang say AND gate. Okay, Dylan also say AND gate. Now we are talking about the inner controller. So O or N. So answer is also AND gate. Okay, the inner controller also we are using AND gate. Okay, why? Now why we use AND gate in the inner controller? For what? What is the reason of using AND gate in the inner controller? It is to on the washing machine or to start the washing process, to begin the washing process. So the washing system can operate, can switch on. Okay, so this is the reason of choosing AND gate in the outer and the inner controller. So finally, which washing machine are you going to buy? Which one is a better choice? P, Q, R, or S? Okay, so you can refer back to the table. So which one is a better choice? P, Q, R, or S? And the choice is, we choose washing machine Q. Choose Q. Why we are choosing Q? Yes, Welia, we are choosing Q. So you write back all the characteristic for Q. Okay, all the characteristic for Q. It has a high load capacity, have a mass sensor, it use AND gate for both inner and outer controller. Okay, so we choose Q because it has a high load capacity, it has a mass sensor, and it applies AND gate for both inner and outer controller. Okay, Anybody wants to join me in the studio here? I can send you the link so you can go into the StreamYard, accompany me up here. Ada yang nak naik tak? Siapa yang internet dia kuat tu, you can click on this StreamYard link and you can join me in the studio as I am alone here today. You can click on this link. Boleh klik link ini so you can join me in this studio. Okay, class. So that goes for question 12. Okay, question 12. So you can screenshot this answer and then you can refer back to them. Alright. Okay, next. Question C. Okay, question C. Now you're given diagram 12.3. It shows a light control switch to turn on the bulb. Okay, to turn on or to turn off the bulb. So I zoom the diagram for you. Okay, this is diagram 12.3. Okay, you can see there is an ammeter up here and this is a fixed resistor 10 kilo ohm. And this is, what do we call this K? Later you have to write. So this is the base circuit. This is another fixed resistor of 1 kilo ohm. And this is our electronic component J. And you can see there is a bulb, this is the switch, and this is the battery supply voltage to the circuit. Okay, so question number 1, C1, determine the potential difference across CD. So what is the potential difference across CD? Where is CD? So this is CD. Okay, this is junction CD. So what is the potential difference here? Okay, can you state? Yang ini tak perlu kira, you don't have to calculate. Just look from the diagram, you can see the answer there. So what is the potential difference at junction CD? It should be equal to the supply voltage. Okay, it should be equal to the supply voltage. Means the potential difference is, yes, it is 6 volt. Potential difference for CD is 6 volt. Kenapa sama? Because it is parallel. Okay, this junction CD is parallel to the voltage supply. So it has the same amount of potential difference, which is 6 volt. Okay, class? Okay, so now question 2. During daytime, the value of K can be assumed to be 500 ohm. So this is the assumption we made during daytime. So masa hari siang, K can reach up to 500 ohm. And you have to calculate the reading of ammeter in this situation. Okay, so this is where we place the ammeter at. So at daytime, it say K can be reached 5. We can assume the reading for K is 500 ohm. So can you calculate the reading of the ammeter in this situation now where K is 500 ohm? Okay, I give you 1 minute to do the calculation and find the reading of the ammeter. Okay, you may do your calculation now before I show to you the answers. Okay. So for your attendance as usual, after this class ended, you please go back to the video and write your name in class at the comment section of the video. Okay, and if possible, please try to do that before 4 p.m. Okay, because we as a teachers must send in the report for the daily lesson before 6 p.m. every day. So your cooperation is fully appreciated. All right. So later send in your name in class before 4 p.m. Okay, have you find the reading of the ammeter? You want to share your answer? What is the reading of the ammeter? During daytime, where K is 500 ohm. Okay, anybody finish calculating the reading of the ammeter? Okay, so this is what the formula we can apply. Okay, in order to find the reading of ammeter, you can use V equal IR. Okay, so V equal IR means we refer to junction CD. Okay, in CD, the ammeter is connected in series with this resistor 10 kilo ohm and also with this K. Okay, so the total resistance is 10,000, 10 kilo ohm plus 500. So the total resistance in this junction CD is 10,500 ohm. So the voltage is 6. So by this we can find the current, and the value of the current is 5.71 times 10 negative 4 ampere. Can you please recheck for me this answer? Is it the correct value or not? Okay, please recheck this answer. It is the correct value or not. 5.71 times 10 negative 4 ampere. And again, class, please don't forget to write the unit as well. Okay, we are calculating for ammeter reading, means current. So the answer must be in unit of ampere. Okay, ampere. So is this answer correct? Can you please check for me? 5.71 times 10 negative 4. Okay. Okay, next. Okay, next question. Question number 3. Okay, question number 3. Now in the dark. Okay, thank you, Dylan. Correct. Okay. Okay, now in the dark, potential difference across component K is 5.4 volt. Okay, so this is the statement you are given. And J is activated. So now calculate the value for K. Okay, now you are given a new situation in the dark, mean at night. Okay, or when the surrounding is dark, potential difference across component K, so this is component K, is 5.4 volt. Okay, 5.4 volt. And J is activated. So J is the transistor. Before that, can you name what is this component K called as? Can you tell us what is this electronic component K called as? Apa nama component K ini? J is transistor, NPN transistor. How about K? Can you recognize this symbol? It's like a resistor, but it has two arrow shows here. So this is, what is the name of this component? Apa nama electronic component ini? K. What is the name of this electronic component K? The name. Light dependent resistor. Yes, very good. Vinci, LDR. Okay, the name for K is LDR, or the full name is light dependent resistor. Okay. So the potential difference in dark given 5.4 volt, and now J is activated. So calculate the value for K. Okay, is it calculate the value for K? Am I typing the right answer? Cheng Guang Heng, it is not rheostat. Okay, this is not a rheostat, but it is a light dependent resistor. Okay, light dependent resistor. So how to find the value? Actually calculate the value for mean the resistance for K. Okay, the resistance for K. So now how to find the resistance for K? So first we can find how much current flow in the circuit. I think I showed the answer too fast. I should give you a few minutes to try on first, but never mind. Okay, so you can try to calculate later. So first, to find the resistance, we find how much current flow in K now. Okay, when the voltage is 5.4. At daytime, the voltage means now the voltage is dropped from 6 up to 6 drop to 5.4 volt. Okay, so we calculate I, where V is 0.6. So this is the voltage from the supply. I, how many when R is 10 kilo ohm. Okay, now this is 10 kilo ohm. So we want to count how much current now flow through the ammeter. So it is 6 times 10 negative 5 ampere. Okay, so means now 6.5 6 times 10 5 ampere of current flow into K. Okay, current of 6 times 10 negative 5 flow into K. So the voltage of K is given now 5.4 and the current flow is 6 times 10 negative 5. So by this we can find its resistance. You boleh kira the resistance. RK mean resistance for K. So the resistance is 9,000 ohm. Is it correct? Can you check the answer? The value for R is 90,000 ohm or 9 times 10 to the power of 4 ohm. Okay, remember first we calculate how much current flow to K by applying V equal to IR. V is the total voltage supply to the circuit and R is the resistance up here. So current of this much flow into K. And with the given voltage and current, we can find the resistance as 90 ohm. Or you can also calculate R in this way. You boleh guna this equation for potential divider. Okay, this equation you can see in our physics module for electronic. You can check this equation from there. Okay, V1 equal to R1 divided by R1 plus R2 V. So we want to find this value for R1. Alright, V1 is the voltage of the electronic component K and V is the total voltage supply. So R1 is the above resistance 10,000 and R2 in sorry, this one is R2. We are finding R1. Yes, any question? Liu, is this Kwang Yu? Liu Kwang Yu, are you? Is it you? Liu Kwang Yu. Why is the voltage 0.6? Which one? 0.6 is the main voltage for this one. Okay. 0.6, sorry. Oh, it's supposed to be 0.6 or 6, sorry. Supposed to be 6, right? Macam cikgu silap di sini. Yeah, very good. Thank you very much for reminding me. Actually the voltage need to be 6. You tolong betulkan di sini kelas. Cikgu tak perasan, saya dah silap. So voltage is 6, not 0.6. Oh, sorry, Kwang Yu. Now I know why now is 0.6. Okay, because now, okay, you see, we are now talking about junction CD, right? Okay, junction CD. Okay, for junction CD, 6 is the total voltage. Okay, for V equal to IR here, 6 ini is the total voltage supply to the whole circuit. Okay, but now we want to find resistance for K. So when you consider junction CD, it's now stated here for K is 5.4. So for K down here is 5.4 volt. Mean the voltage above here will be 0.6. Okay, so up here is 0.6. So if you add 0.6 plus 5.4, it will give you the total voltage of 6. Are you clear now? So ini tak salah lah, ini betul 0.6. Sorry for the confusion I give to you just now. Okay, so above here, down here the voltage is 5.4. So the voltage up here is 0.6. So if you total them 0.6 plus 5.6. So they will give you a total voltage of 6, similar to the external voltage supply. Okay, are you clear now, Kwang Yu? Boleh jelas? The rest of you, are you clear why we use here 0.6? Okay, so 0.6 is the voltage up here with flow through the 10 kilo ohm resistor, and the one that flow to the K is 5.4 volt. So to find the current flow in the ammeter, so we use 0.6, and this current, since 10 kilo ohm resistor and the K is connected in series, so the amount of current flow to them is the same. So by this, the resistance for K is 90,000 ohm. Okay, thank you, Vinci, for responding. Okay, or if you don't want to use this equation, as I mentioned just now, you have another option. You can use the equation for the potential divider. Okay, this equation you can refer from our electronic module. Okay, so where V1 5.4, V1 refers to the voltage for K, and R1 is the resistance for K, R2 is the resistance for the above 10,000 ohm resistor, and V is the total voltage at junction CD. Okay, so by this we also find R1 is 90,000 ohm. Okay, 90,000 ohm. Okay, so anyone is applicable. Mana-mana satu pun you boleh guna. Alright. Okay, now we go to question 16. Actually, this is supposed to be question 13, but I don't know why I typed question 16, so it's okay. It's not a big problem. Again, this is an essay question on the final chapter, last chapter, radioactivity. Okay, so radioactivity. So first and foremost, you are given this table. It shows the number of protons, the number of neutrons, and the nuclear number of 3 isotopes of hydrogen. Okay, we learned before in the class, hydrogen, this is the 3 isotopes for hydrogen. The first one is called as hydrogen. The second one, what is the name? The second isotopes for hydrogen, can you tell me the name for this? This one is H2. This one is called H3. So for H2, what is the name for this hydrogen isotope? If H1, it is called hydrogen. For H2, the name is, anybody remember the name? And for H3, what is the name for the isotopes? For H1, we call it as a hydrogen. Yes. H2, we call it as deuterium. Okay, H2 is called as deuterium. Deuterium. I type the name for you here. D-E-U-T-E-R-I-U-M. Okay, deuterium. And then when H is 3, we call it as tritium. Okay, the name of the isotope is tritium and deuterium. Okay, so deuterium and tritium is an isotopes for hydrogen. H1 is called hydrogen. Yes. Okay, so the question is, complete the following sentence by ticking the correct word. Okay, the first question, A. What is the charge for proton? This is a very basic question. Charge for proton, class, positive or negative? Positive or negative? Charge for proton. Siapa yang salah ni tak sepatutnya lah. Okay, you shouldn't get wrong for this question. So the charge for proton is positive. So we tick inside the box. Remember, when you have to tick, you must tick inside the box given. Don't tick outside or below or above the box. Okay. Second, this is also a basic question, a basic concept. What is the meaning of isotopes? You also learn in chemistry. What is the meaning of isotopes? Can you share your answer? What is the meaning of isotopes? Okay, what is the meaning of isotopes? Can you type your answer in the live chat? What is the meaning of isotopes? It's not hydroxonium, Jinjay. Okay, it is. For 2 is called deuterium. For 3, H3 we call as tritium. Okay. So class isotopes, what does isotope means? So somebody is typing their answer. Let me see. Jack. Same proton number but different nuclear number. Wei Liang also says same number of proton but different number of nucleon. Okay, so this is a few answers shared by your friend. Same proton number, different nucleon number. Another answer, same number of proton but different number of nucleon. So both are acceptable. Okay. Tapi you letaklah sedikit di depan tu apa yang same. Element. Okay, you add the word element at the front or atom. Atom of the same element with same proton number but different nucleon number. Or you can say element with same number of proton but different number of neutrons. Okay, elements with same number of protons but different number of neutrons. Or it can be elements with same proton number but different nucleon number. Okay, so please be clear. Don't forget to write the word element at the front. Okay, element or atom of the same element with the same proton number but different nucleon number. Alright. Okay, now C, question C. Oh, the answer is appear already. Never mind. Okay, C1 and C2. State the value of A and X. Okay, so where is A? Where is X? Okay, A is here. A, you have to write the nucleon number for the deuterium. Okay, so the nucleon number is given on top. Alright. While for X, you have to write the proton number for X. X ini berapa? See, proton number must all be the same. 1, 1, 1. So X will be 1. Okay. While for A, it is 2. Jangan terbalik So you have to look carefully. Where is A? Where is X? So answer A is 2 and X is 1. Alright? Okay. So now let's go to B, a long essay questions. Radioisotopes is used as a tracer to determine the rate of absorption of fertilizer by plants. You are required to investigate the characteristic of radioisotopes as shown in the table below. Okay, for your information, okay, radioisotopes has been used in many fields. It used widely in various fields around the world. Okay, radioisotopes is benefits in either medical field, okay, in technology. We are using also a radioisotope in archaeology to determine the age of a fossil, for examples. And also it is used widely in agriculture and industries as well. So in agriculture, we are using radioisotopes to determine the rate of absorption of fertilizer by plant. How well the plant absorb the fertilizer supplied to them. So we can detect using a certain type of radioisotopes. So if you refer to this table, you are given 4 choices of radioisotopes, namely as W, X, Y, and Z. And they give you the 4 characteristics for each. First is the state of matter. Okay, you are given either solid or liquid. Okay, and second is the half-life. Okay, half-life, long or short. Okay, long or short half-life. And you can see here for W, the half-life is very short, 5 minutes. Okay, X, 2 years. For Y is, you can say moderate, 14 days. Okay, 14 days we can say moderate. And for Z is 20 years, long. So here we have a long, short, and moderate. Okay, and the type of ray emitted by the radioisotope, you are given two choices, gamma or beta. Okay, gamma or beta. And the fourth characteristic is the type of detector used. You are given with the spark counter, you are given two choices, spark counter and GM tube, gigamuller tube. Okay, so what is the question? Explain the suitability of characteristic of the radioisotope to be used as a tracer and determine the most suitable radioisotope that can be used to detect the rate of absorption of fertilizer by plants and give a reason for your choice. Okay, so first and foremost, what must we do? Form your table. Okay, don't forget to form your table of characteristic and reason. Okay, please respond to me. The first characteristic, the state of radioisotope. It is better to be in solid or better to be in liquid? Which one? Solid or liquid? What do you say? The state of matter. Okay, please share your answer, share your opinion in the live chat. Solid or liquid? Which one is your choice? Min Swan say liquid. Jinjie says solid. William say liquid. Common Cubing says solid. Dylan says solid. Kenapa you kata solid? Why you say liquid? So we should remember this is to be applied to a plant. Okay, to apply to the plant. Okay, so yang mana kita nak pilih? So the answer is liquid. Okay, it is liquid. It should be in liquid. The state of matter is liquid. Okay, please mention the characteristic as well. State of matter. Okay, state of matter is liquid. Yes, Yutong, it is liquid. Okay, Jack, yes, liquid. Okay, why you say liquid? What is the reason? Easily to be absorbed by plant. Very good, Wei Liang. Yes, easily to be absorbed by plant. Easy to absorb by plant. So the root will absorb the radioisotope easily. Alright. Okay, next, second characteristic is talking about the half-life. Yes, half-life. Okay, don't just say easier. Easier in what? Okay, easy to absorb by plant. Okay. Second characteristic, the half-life. So which one? Short, medium, or long? You are given three range for the half-life: short, medium, long. So which one is a better choice? Very short, 5 minutes, 2 years, 14 days, or 20 years. But please don't mention about the years. Remember, never mention about the number. Just mention high, low, and in this case, we are given medium. Okay, Leong Jingqian say short. Okay, short. For short here, we have 5 minutes. Okay. Please think logically. Does 5 minutes enough to give the time for the plant to absorb, for you to study the rate of absorption? Dylan say medium. Okay, any other answer? Ada jawapan lain? Jinjie say 14 day moderate. So the answer is half-life of radioisotope, we say medium or moderate. Okay, half-life. Write also half-life. Okay, write also the characteristic. Half-life of radioisotope is moderate. Okay, half-life of radioisotope is medium. Okay, why? Why we must choose a moderate or a medium half-life? Okay. So what is the reason? Okay, the answer is correct, moderate or medium. And what is your reason of saying so? Why we choose a medium half-life or a moderate half-life of radioisotopes? The reason is so that, anyone? The reason is Radioisotope will not remain in the plant. Okay, Jinjay said radioisotope will not remain in the plant. Okay, any other answer? Ada jawapan lain? Okay, this can be accepted. Boleh diterima, radioisotope will not remain in the plant. But the best is to say, so can be detected in a suitable period, or you can say enough time, okay, for the enough time to detect, okay, enough time to be detected, okay, by the plant. Okay, can be detected in a suitable period. Good enough time to observation. Ini bolehlah diterima. Okay, enough. Okay, enough time to absorb. Okay, or to absorb. ABSORB. Okay, for the plant. So we can study. Kalau if 5 minutes, it is too short. Okay, it doesn't absorb yet, but the radioisotope will decay. Okay, because the half-life is very short. Not enough time for the plant to absorb yet, then it is already decay. So 14 days is just a good period. Okay, 14 days, medium. Okay, next characteristic. Okay, what about the third characteristic? Okay, which radiation that is suitable for the radioisotope? Gamma or beta? Okay, you want to choose a radioisotope which emit which radiation? Emit gamma or emit beta? Which one is less harmful? Gamma or beta? I give you the clue already. Radiation emit by the radioisotope. We choose the one that emit beta or we choose the one that emit gamma? Yes, common cubing. Who is this common cubing? Just now sudah lupa. Beta, yes. So we choose a radioisotope which emit beta. Okay, so the reason is kenapa? Because beta is less harmful compared to gamma. Okay, so the type of ray is beta. It is less dangerous, or you can say less harmful compared to the radioisotope which are emitting gamma radiation. Okay, oh sorry Tat Guan. Okay, common cubing. Okay, Tat Guan. Okay. Okay, now the type of detector. Okay, I show you too fast the type of detector. Spark counter or GM tube. So we choose GM tube. Okay, the type of detector used is GM tube. Okay, why we are choosing GM tube? Okay, terima kasih Cikgu Badrul kerana bersama-sama. Okay, so it can detect the ray easily. Okay, it can detect the ray easily for GM tube. For spark counter, it took longer time to detect. Okay, to detect for the sensor to detect the presence of the radioisotope. So it is better to use GM tube. Okay, can detect the ray easily. It is more sensitive, okay, to the presence of radiation. Okay, Wei Liang, am I answering your answer? GM tube can detect quickly compared to a spark counter the presence of radiation. Alright, and normally GM tube it works better with beta. Okay, GM tube it works better with beta. Alright. Okay, so which one is the better choice? W, X, Y, Z. So which radioisotopes will you choose? What is GM tube? GM tube is a Geiger-Müller tube. Okay, the name is Geiger-Müller tube. Yes, can detect beta. Jinjie. Yes. GM tube can detect beta ray. Okay, GM tube is Geiger-Müller tube. It is the name of the devices which we use to sense the presence of radiation and normally beta. So Yutong say why? Yes. So we choose radioisotope Y. Okay, we choose radioisotope Y. So how to conclude our answer, how to get the full marks? So you mention back all the characteristic for Y. Okay. So because Y is in a liquid state, it has medium half-life, it emits beta ray, and it uses GM tube as a detector. All right. Liquid state, medium half-life, beta ray, and GM tube as detector. All right. So by this, we can score maximum of 10 marks, 10 markah. Okay. So if you find this question in the future, let's say it's come out in the SPM. So remember, this is how we choose a characteristic of a suitable traces. Okay, suitable radioisotopes to be used as a traces in studying the rate of to study the rate of absorption of fertilizer in plants. Okay. So do we have any remaining question? Ada lagi kan? Okay, now let's take a look at the final question, question C. Okay, question C, if you remember in your trial exam, I placed one question for counting for finding the mass of defect and the energy release in a nuclear fission, okay, in a radioactivity. Okay, so the question for C, a nuclear reaction is represented by the following equation. So this is the equation you are given with. It shows a uranium, okay, and neutron. Okay, so can you tell me by seeing this equation, what type of reaction involved here? What type of nuclear reaction involved here? Is this nuclear fission or nuclear fusion? Can you state which one? Cheng Guangheng, I need to screenshot the previous screen. Okay, okay, I go back to the previous screen. Okay, you can take the screenshot now. All right. Okay, are you done? Guangheng, have you take the screenshot? Okay, so we go back to the current slide. Yes, it is nuclear fission. Yes, very good. Okay, Jinjay, Dylan, it is nuclear fission. Okay, in nuclear fission, we already learned in the class, a uranium is bombarded with neutron. Okay, we bombard a uranium with a high moving speed of neutron. So what will happen to this uranium? It will split. Okay, the uranium will be split into a lighter nuclei. So it will split into barium and krypton as shown in this equation of product. And this process release 3 new neutron and a very enormous energy. Okay. And down here is in Bahasa. And this is the information given. They give you the atomic mass unit for uranium, for barium, krypton, and neutron as well. Okay, so this is the atomic mass unit. And down here is the conversion, how to convert one atomic mass unit into kilogram, where one atomic mass unit equivalent to 1.66 times 10 negative 27 kilos. Okay, welcome, Wan Heng, most welcome. Okay, first question, based on the equation, calculate the mass defect. Okay, so how to find the mass defect? So remember class, how to find the mass defect? The total mass of the reactant minus of the total mass of the product. Okay, the total mass on the left side minus the total mass on the right side. Okay, so how we do this? Okay, you can calculate the total mass defect if you didn't try yet. Later, I will show you the answers. Okay. So in this type of question, you must be very careful because we are playing with a very lot of numbers. Okay, so don't miss even one digit of this number, and you may do your plus minus, okay, carefully. All right. Okay, so this is how we do the mass defect, how we count the mass defect. Okay, on the left side, the reactant, this is the mass of the uranium plus the mass of the neutron minus, okay, on the right side, we have 3 products. This is the mass for barium, mass for krypton, and this is the mass for neutron. Since we have 3 neutron, so we multiply with 3 at the front. Don't forget to multiply with 3 at the front. And you count, it will give you 0.18606 atomic mass unit. Okay, don't forget to write the unit as well. Okay. So this is the answer for the mass defect, 0.18606 U. If they ask you to place the answer in kilogram, so you have to convert into kg by multiplying this value with 1.66 times 10 negative 27. But for this question, it doesn't state in what unit you have to place, so enough to leave it in a unit of atomic mass unit, U. Okay, and question 2. Energy release. Okay, how to find how much energy release in this process. Okay, how to find how much energy release in this process. Can you share what equation we can apply here to find the energy release? Can you type the equation which we apply for question C2 to find the energy released? What equation we are applying here? Okay, yes, Richard. Sorry, Jinje. Jinje. I think Richard is your father's name, right? Okay. So E equal to MC theta. Yes, Dylan, very good. E equal to MC theta. Okay. So you just do the substitution. Okay, it is E equal to MC theta. Yes. Okay, E equal to MC theta. Okay, again, we just do the substitution where M, okay, this M must be in kilogram. Okay, when you apply E equal to MC theta, please bear in mind this M must be in kilogram. So this is the mass in atomic mass unit 0.18606 multiply with 1.66 times 10 negative 27 to convert it into kg. And C is the speed of light. Okay, speed of light. 3 times 10 to the power of 8. And don't forget the square as well. Don't miss the square or else you will come out to the wrong answer. Okay, so by this, the amount of energy released in this process is 2.7797 times 10 negative 11 joule. Okay, remember when writing the final answer, you can write from 2 up to 4 decimal places. Okay, don't have to, no need to write for so many decimal places, from 2 to 4 decimal places. If you write 2 decimal places for this answer, mean it will be 2.80. Okay, 2.80 times 10 negative 11 joule. Okay, don't forget to write the unit as well. We are counting for energy. So energy is written in joule. Okay. C represent for what? C, what is C? E equal to mc squared. E is the energy, m is the mass in kilogram. So what is C? Wei Liang asks, what is C represent for? If you look at the value, I think you can recognize C is 3 times 10 to the power of 8. So what is this? 3 times 10 to the power of 8. Speed of light. Yes, very good, Jinjie. C represents speed of light. Okay. Why we are using C in this equation? Okay. The radiation, okay, when the nuclear fission occur, okay, the product, the ray that produced from the process is travel at the speed of light. So that's why we are taking speed of light in the equation to count how much energy mass multiplied by speed. So we'll give you the energy provided. Okay, so remember Wei C is speed of light. Okay, thank you Jinjie. It is true, speed of light. Okay, class. So that's all for question C1 and C2. Remember, please show your calculation in a proper way, starting from what equation you are apply, and then how you do the substitution, and the final answer must come together with the corresponding unit. Okay, unit must be included in your final answers. Okay, that's all for module Cakna. So we have finished discuss question number 1 up to question number 13 in these 3 classes. So I would like to say thank you. But we are not finished yet. Don't leave yet. Okay. We still have a few more minutes. Okay. So let's try this extra exercises. Okay. Ini senang saja, objective question. Okay. I prepared 10 question for you. Okay. Let's check on them. Okay. So you can close your module Cakna, and now let's focus on this extra exercises on question paper 1. All right. Okay, so question 1. Can you tell me what is the answer? Which of the following quantities is a scalar quantity? So which one is a scalar quantity? A, B, C, or D? Was it force, density, weight, or momentum? Okay, scalar quantity. Scalar quantity means what? Scalar quantity means what? Scalar quantity is a quantity which has magnitude but no direction. Okay, so which one is the answer? Which one has magnitude but no direction? Force has direction or not? Force is a vector. It has magnitude and direction. How about weight? Weight also is a vector. It has magnitude and it has direction. Weight acting downwards. Momentum. Momentum also a vector. Okay. Momentum also vector. It shows direction. So the answer is density. Okay. Density is a scalar. Who's answering B? Okay. A lot of you answering me. Vinci. Means 1A. Force is a vector. Means 1. Okay, Songjun B, yes, very good. Waylon also say B, Jack also B. So the answer is B. Density is a scalar. Okay, now question 2. Okay, question 2. Okay, for question 2, okay, you are given diagram 1. Okay, the question is on electricity. It shows a measuring tool Q in an electric circuit. Okay, so what is the physical quantity measured by measuring tool Q? So this is measuring tool Q. The question asks you, Q is used to measure what quantity? So is it to measure light intensity? Is it to measure electric current? Is it to measure potential difference? Or is it to measure electromotive force? Okay. So how to answer this? So we have 2 possible answer. Ada 2 possible answer here. It can be B or it can be C, right? So the answer is either B or C only. So now we want to know Q. This Q is ammeter or voltmeter? Okay, ammeter or voltmeter. How to know? Yes, the answer is B. Very good. Okay, it is B to measure electric current. Okay, how to know this is an ammeter and not a voltmeter? Okay, you look at how it is connected. Okay, now you can see that Q is connected in series, right? It is connected in series with the battery. So if the device is connected in series with the battery, it is ammeter. For voltmeter, we connect it in parallel with the dry cell or the battery. So if the diagram now connect parallel, so the answer will be C. It is a voltmeter to measure potential difference. But now it is connected in series, so we know it must be an ammeter. Ammeter is used to measure electric current. Okay, very good. Okay, now question question 3. A, B, and C show the shooting marks on a target. So which shooting mark can explain the concept of precision of a measurement? Precision, precise. Okay, what is meant by precision, precise? A, B, C, or D? Okay, which one is precise? A, B, C, or D? Okay, remember in measurement we have precise, another one we have accuracy. Precision and accuracy. So they ask you for precision. So precision will be C. Yes, so precision is C. C. See, you can see all the data is precise. They are fall at the same places all the time. Okay, mean it is precise, but not accurate. So answer number 3 is C. Okay. Next, number 4. Okay, number 4, you're given a ticker tape. It shows an object at constant acceleration. So the keyword is constant acceleration. So which one shows a movement at constant acceleration? So which one? A, B, C, or D? Constant acceleration. Was it A? They ask you for constant acceleration, not constant velocity. Okay, constant acceleration, not constant velocity. So which one? Is it A? Are you sure, Vinci? Wei Lun, Jack, Min Suan, Jinjie say B, number 4. So which one shows constant acceleration? So which one shows constant acceleration? For A ini it shows what? For A it shows constant velocity, right? So you can cross. A is totally wrong. B. B shows what? B shows deceleration, right? B show deceleration. Okay, where the distance is decreasing from the front to the back. The distance is decreasing, so it shows deceleration. Okay, while for D, it shows inconsistent distance. So ini inconsistent distance. So sometimes it here is accelerate and below here it decelerate. So the answer is B. Okay, it shows a constant acceleration. So answer for number 4 is B. Okay, B. Jangan terperangkap dari constant acceleration. So not constant velocity. Okay, number 5. Okay, those in 5C, you can move to your BM class because if I'm not mistaken, it started at 11. Okay, and later you can go back and watch this video to get the answer for the remaining question. Okay, number 5. Okay, now you're given diagram 2. It shows the water flows out from a water tank. Okay, there's a water flow out from this water tank. So the question is, which of the following statement, is true after the water continuously flow out for some times? Okay, so which one is true? Which statement is true after the water continuously flow out for some time? So was it A, inertia of the water tank decreases? B, acceleration of water drop decreases? C, density of water in the tank decreases? And D, time for water drop to reach the ground decreases. So which one do you think is the answer? Yang mana? Which statement is true after the water continuously flow out for some times? Okay, continuously flow out for some times. Somebody says A, somebody says B, somebody says, ada orang say C, anyone say D? So which one is the answer? Ini question number 5. Okay, it flow out from this day. So after some time, so what will happen? So the answer is it something to do with the inertia? Anything to do with the inertia? I don't think so. So you can say the acceleration of the water drop decreases. Is it? Okay, acceleration of the water drop decreases. So answer is B. Okay, actually this question where I get from, it is the Penang trial. Okay, Penang MPSM, which I already placed in my Telegram group. So those who are joining my group, you can get this answer from there. But in the marking scheme, the answer is given as A, which is incorrect. Okay, inertia of the water tank decreases. Okay, this is nothing to do with the inertia. Okay, but the answer is B, acceleration of the water decreases. All right. Okay, now next question, number 6. Okay, number 6. Okay, number 6, you are given a velocity time graph. Okay, a velocity time graph for an object. So if the total distance travel is 600 centimeter, determine the value of t. Ini you have to do a bit calculation. Okay, number 5, just now the answer is B. Yes. Okay. If the total distance travel is 600 centimeter, determine the value of t. Okay, so how to find t? Remember, this is a velocity time graph. Okay, total distance travel class. For velocity time graph, total distance travel is given by the area under the graph. Okay, so this is the graph we have from 0 to time is 40. So this graph is divided into 3 sections. First section, the first 10 second, we have a triangle. Okay. Second section from 10 to t second, it is a rectangle. Okay. And then from t to 40 second, again, it is a triangle. So you add all these 3 area, it will be 600 centimeter. So by that, you can find the value for t. Okay. When you count, t is 30 second. So what you do? Half multiply by 10 multiply by 20 plus here is t minus 10 multiply by the height is 20 for triangle plus area for this triangle half multiply by 40 minus 3 multiply by the height 20 equal to 600. Okay, so by this, you can get the unknown value for t. And if you calculate, t will be equal to 30 second. Okay, 30 saat. T is 30 second. Okay. Okay, now for question 7. Okay, question 7. Which of the following measures shown in the diagram does not reduce the impulsive force? Okay, you please repeat the question. Please read the question carefully. It say, which of the following measure shown does not reduce the impulsive force? Okay, look at the first answer. This boy is jumping from a fence and while landing, he bent his knees. So will this action reduce the impulsive force? Yes or no? And then B. Okay, B, this car is made to be easily crumpled zone on the vehicle. So the front part is designed so it will be easily crumpled during accidents or during collisions. While for diagram C, okay, this lady is wearing a seat belt. So would the seat belt help in reducing the impulsive force? And D, this boy is having a high jump event and there is a mattress placed there as a landing area. Okay, we go back to the question. It say, which of the following measure does not reduce the impulsive force? So which one is the answer? So answer is C. C can be related to inertia. Okay, C is related to inertia, not impulsive force. For A, B, and C, all will prolong the time of impact. So when the time of impact prolong, definitely yes, the impulsive force will be reduced. Okay, so answer is C. Yes, answer is C for number 7. Okay, question number 8. Question number 8 again to do with the calculation. Okay, calculation. So what do we have here? It shows a 1.2 meter height of a girl throwing a ball vertically upward at a velocity of 20 meter per second. So you have a ball in your hand, you throw this ball upward with a velocity of 20 meter per second. So the ball move upward at velocity 20 meter per second. And you start throwing it at a height of 1.2 meter from the ground. Okay, as shown in this diagram. So the question is, determine the total distance taken by the ball until it reached the ground. Okay, determine the total distance taken by the ball until it reached the ground. Okay, so how to find the total distance? So the total distance means the distance here when you throw the ball upward, and then this distance when it come back at this height plus this, okay, from here until it drop to the ground. So we have 3 distance to be considered. First, when you throw it up. Second, when it drop back to this height. And third, from this height to the ground. So this one we know already. It is 1.2 meter. So we have to find the distance up here. Okay, from the head of the girl and until it reaches the maximum height. Okay, so how to find this height, class? What happens? So you start throwing with velocity of 20 meter per second. Okay, so which means U is 20 meter per second. So you can jot it down. U 20 meter per second. And when the ball reached the maximum height, what happened to its velocity now? When the ball reached maximum height, what happened to the velocity? When it reached maximum height, what happened to the velocity? Velocity will be 0. Yes, very good. At maximum height, velocity will be 0. So you can jot down V is 0 meter per second. Okay. So we want to find distance S. Okay, S we leave as a question mark. So we know U is 20, V is 10 meter per second. Okay, how about gravity, G? What is the value for G here? G is 10 meter per second squared. So we can take G 10 meter per second squared. So we have U, we have V, we have G. How we can combine all this information in order to find S? S. So which formula we can apply here? So you can apply S equal to UT plus half AT squared. A is G lah, gravitational acceleration. I repeat, you can apply S equal to UT plus half AT squared, the linear motion equation. So we want to find S where U is 20. Sorry, sorry, not this equation because time is not given. Okay, you can use V squared, U squared plus 2 GS, 2AS. Okay, you can use, sorry for the wrong equation. Okay, we cannot use T because T is not given. So we can use the linear motion equation which supply with U, V, S, and A. Okay, so V squared is U squared plus 2AS. Okay, so V squared is now 10. V squared is 0. So U is 20. Okay, so you place 2AS. S. So A is the gravity. Now the value is negative. Okay, so for A, the value is negative because we throw the ball upward, so it will be against gravity. Okay, it against gravity, so we place a negative 10 and we can find S. Okay, did you get the picture? Okay, I give you the equation. V squared equal to U squared plus 2AS. Okay, so V squared is 0, 0 squared equal to U squared is 20 square plus 2. A is negative 10. Say, means we throw the ball upwards, so it against gravity and S. So by this, can you tell me what is the value for S? Okay, please calculate the value for S. Okay, please calculate the value for S. So you will get S is 20 meter, right? When you calculate V squared equal to U squared plus 2AS. So you will find S is 20 meter. Okay, so it means 20 meter from this height. 20 meter upwards, and it also drop at the height of 20 meter here. Okay, and down here another 1.2 meter. So we are finding distance. So distance mean from here 20 meter plus 20 meter plus 1.2 meter. Okay, so the answer is 41.2 meter. Answer is donkey. Yes, very good, means one. Answer is donkey. Okay, did you get the equation? I give you the equation again. We apply V squared equal to U squared plus 2AS. Okay, so the distance, the total distance is 41.2 meter. 20 plus 20 plus 1.2 meter. Okay. Okay. Okay, now we go to the last two question, 9 and 10. Okay, ini senang saja. Okay, this is on forces of equilibrium. It shows two similar towing boats tow a vessel. So this is the vessel, the big ship. Which diagram produce the highest acceleration? Okay, which diagram produce the highest acceleration? Okay, for this question, actually you don't have to calculate. You don't have to make any calculation. Okay, the first two diagram, okay, for A and B, this is the angle between the two towing boat, 20 degree. And here we have the angle 40 degree. And for C and D, it is 60 degree and 80 degree. So how to know which diagram produces the highest acceleration? So the clue is you have to find which one will produce the highest resultant force. Okay, the highest resultant force acting between these two towing boat. And I give you the clue, the highest resultant force will given by the smallest angle. Okay, the highest resultant force is given by the smallest angle between the two towing boat. So which one give us the smallest angle will supply to you a highest resultant force. So highest resultant force mean highest acceleration acting. So it's very obvious. The answer is A. Yes, very good. A. Remember the keyword. Smallest angle will give you the greatest or the highest resultant force, and highest resultant force will create highest acceleration. All right. Okay, last question for today. Question 10. Okay, which of the following diagrams show the smallest work done? Okay, this is very simple, the smallest work done. Okay, we have A, B, C, and D. Which one? So the answer is A. Actually, the person in A does not do any work. Okay, he doesn't do any work. The work is 0. Why 0? Because he is pushing on the wall and the wall is not moving. So there is no displacement, mean there is no work done. Okay, so answer for number 10 is A. Yes, very good. So this is all from question 1 is question 10. It actually it tests on your understanding of concept. Okay, understanding of concept. So your concept must be very, very strong in order to solve all these question. Okay, class. So for the remaining question, you please go to my Telegram channel. Okay, you can get all the question from there. I give all paper 1, paper 2, and paper 3 together with the answer as well. So please go and check them. So I think that's all for today. I'm sorry we are drag a bit. It's now 7 minutes to 12, but I would like to say a lot of thank you to all of you for stay with me from the beginning till the end. So I hope you will complete all these exercises in Module Cakna. And don't forget to write your attendance and class in the comment section in this video later on. And it must be done before 4 p.m. Okay. I'm sorry for the all the apa-apa kekurangan yang cikgu sampaikan, all the confusion before this. So I hope you are clear with all the question we are discussing today. And for next Wednesday, we are discussing more about a few examples on paper 1 and paper 2. Or you want to request for a special, you want to request for a certain topics. Which one you want us to discuss example of question, or you want me to discuss a question on certain topics only? What do you say? If you want me to discuss on specific topics, mean for example heat. So for next Wednesday, we are focusing only for question involving heat. Or you want me to discuss about light. So we just focusing about question on light. So later you can write your opinion in the comment section also. But again, thank you very much for your cooperation, and I hope to see you again on next Wednesday. Okay, till then, stay safe, stay healthy, and thank you for being with me today. Okay, again class, thank you very much. Okay, and bye for now.